All right, we're going to start working on 4.2, graphing polynomials. I wanted to just make certain folks are really mindful of the wording. Mathematics, as we said, is a very difficult language to translate. It can be very unforgiving if you get it wrong, if you translate it wrong. So I just kind of wanted to point out, like, A dividing B and A divided by B. Those are two very different things. And it looks very, very similar when you're reading it. So translating it from the English into the math, be careful with your translation, just from the standpoint of a lot of times they look so similar. And it's okay to go back and, double check your work or triple check. I usually have to triple check. So, and if I have to, then it's no big thing if you do, right? All right, so anyway, graphing polynomials. And I'm going to give you the esoteric, abstract version, and then we'll talk about what this really means. All right, so if P is a function, P is a polynomial function, right? P of x, and it has the degree n, then the graph of the function has, at most, n real zeros, and thus can have n x-intercepts, and at most n minus 1 turning points. Okay, and the turning points on a graph, we normally think of them as being minima, maximum, all of that. It's not too bad. It's not too difficult to understand in that regard. So what we have here is, I'm going to give you an example. We have the negative 2x to the fourth, and then I have plus 2x to the third. We're going to factor that out here in just a moment. I'm going to just remind folks about the general shape. Remember, when we're looking at the general shape of these things, if you have an even degree, right? If you have an even degree, and we've already talked about what happens when we have a quadratic, this is very similar to that. Anytime you have an even 2, 4, 6, 8, any of those, you're going to wind up with either something that looks, generally speaking, like a quadratic, opening up if your A is positive, and then you're going to have it opening down or frowning if it's negative. All right. So here I have these little squiggles in the middle. That means there's other stuff happening, but the big picture, right, the overall picture is going to be like a parabola, either facing up or down, depending on whether A is positive or negative. And then when we have an odd degree, if our A is positive, we come up, and there's stuff that happens in the middle, and then it continues to go up, right? So you have this place where it can bend a little bit, but as x goes up, your y is going to go up, where if you have a negative A, as your x goes up, your y is going to decrease. All right? So getting back to our function here, our negative 2x to the fourth plus 3x cubed, the degree is 4. So we know that we're going to have it's an even degree, so we know it's going to have a parabola-like behavior. And we're going to determine that we're going to take a look at the leading coefficient. In this case, it's negative. So the parabola is going, the overall shape, the parabola-ish shape, is going to open down. So we're going to have something that looks like this in the big picture of things. So next thing I'm going to point out is that when we factor these guys out, I have x to the third and x to, I'm going to have an x to the first, right? I don't normally write that on there, but it's x to the first. Now remember, if we have an even multiplicity, right, we're going to have just a touch. It touches x-axis. For odd multiplicity, it crosses x-axis. And I didn't mean to write over what I'm already working, or what I already wrote, but in this case, our odd multiplicity crosses the x-axis. And I'm going to remind folks, even though this is a degree of 4, I'm going to have some numbers, right, or some factors of this that can be 1, 2, 3, or 4, right? In this case, I have x to the third, right? And then I have, because I factored it out, and then I have this other factor, which is negative 2x plus 3. All right? So those two are going to set me up for what I need to do. In this case, I don't have any even multiplicity, right? This is an odd with my 3, and then this is an odd with my 1. So when we take a look at this, we're going to have our zeros, right? We have a 0, 0, and then we have a 3 halves, 0, right? Because I've set those two terms equal to 0, solved for it, so I have an x equals 3 halves. So my x is 3 halves and 0. We're going to keep the multiplicity in mind. All right, we have an upside down, we have a frowning parabola-ish shape. In this case, it actually is very much like a parabola. We have our point here at 0, 0, and then we have 3 halves 0, and so it does actually cross, right? We have a negative infinity, a positive infinity, then we've got stuff in between here, okay? So this is going to divide our real number line into 3 intervals, from negative infinity to 0, from 0 to 3 halves, and then from 3 halves to positive infinity. All right? And from what we know, just by kind of working through our degrees and our multiplicity and all of that, we already know that this is going to do something like this. Okay, this may not be perfect, but it's going to be really close to this. All right? There's another way of testing this as well, and if you're ever unsure of if you've got this right, it's like, did I remember all that stuff right? I don't remember what the multiplicity does, if it's odd or even, right? So this is a way to do it. There's another way to do it, and I'm going to teach you that right now. So we're going to have those intervals, right? I'm going to have those intervals that I have my 0, and I'm going to have my 3 halves. All right? And actually, why don't I go ahead and end this here, and then we'll pick up part 2 in just a moment.